Alright guys, welcome back. I'm here to do a video tonight on heat capacity, or we can say specific heat. So I had a former student to send me this question. It's not the exact question, it's similar, so let's go ahead and look at this. It says a shelf has a medium-sized pan that is made of copper. This copper pan has a mass of 375 grams. The pan absorbs 24,800 joules of heat. How much does the temperature of the pan increase in degrees Celsius? The specific heat of copper is 0.385 joules per grams times degrees Celsius. Round your final answer to the nearest degree. So we're going to need an equation to basically answer this problem. So let's go ahead and look at what equation we're going to need. So once again, forgive any type of poor penmanship on my part. It's always hard writing with these sketch pads. But one of the things that we're going to need is a formula, okay? And I told you the formula that we're going to use is basically Q equals, what is it? M times, I really think about this, it's been a while since I used it, M times C, and this C is actually like a capital C, times delta T. Now this is the specific heat equation. Now when I say it's been a while, it's either I either cover this at the very beginning of the year, or I usually cover this at the very end of the year in my chemistry class. And what's funny is I taught things differently this year, and I can't remember if I taught this first or if I taught it, or I haven't taught it yet. I don't know. I honestly can't remember. I have to look back. It's been one of those years. But before we use this equation, let me explain to you what each letter is. Okay, so off to the side here, Q is basically our heat capacity, or our heat. We'll just call it heat. Okay, Q is our heat. And when we mean heat, what we're really talking about is our energy. Okay. Now, this energy can be viewed as being positive or being negative. One way that you know that it's positive is if they tell you that it's absorbed. Okay. If the energy is being absorbed, then the object is being heated up. If the energy is being released, then we know that the object is cooling down because it's releasing its energy, its heat, into the system, or instead of the system, it could be to the outside environment. Okay, so that's Q, and that's what the A and the R stands for, absorbed and released. Okay, M, of course, is mass, and we know with mass it could be units of grams, it could be units of kilograms, but here we're wanting our units to be grams. Now let me tell you why we're wanting our units in mass to be grams. When we're looking at further down in the problem, when they mention the specific heat capacity of copper, they mention that it's in grams. Now if your specific heat value that you're given, or that you had to look up in a table, is given to you but it's in kilograms, you'll need to make sure you convert your mass into kilograms. But here I'm not having to worry because my mass is in grams, so I'm good. Okay, next is C. Now a lowercase c is the speed of light, but a capital C is specific heat. Okay, so let's write that down. Specific heat. Alright, specific, yeah, I know, I had to think. Specific heat, okay? Or you could say our heat capacity. Our specific heat is, it could be several different types of units, but the ones that we're using here is joules per grams degrees Celsius. So anyway, that's that. And then our delta T is just the change in our temperature. Now, I will tell you this. It honestly, now you'll have some chemistry teachers that will tell you, hey, we got to convert Celsius into kelvins, or hey, we got to convert our kelvins into Celsius. Well, honestly, on this one, it doesn't matter because we're looking for the difference in temperature. Granted, it would make more sense if our two temperatures that we could possibly compare, well, I need to make that a T, that our two temperatures that we would compare would be the same units, of course. You know, you want both of them to be Celsius, ideally, but if they were both were Kelvins, it wouldn't be that big of a deal because it's just a different. I done it again. I forgot to write the T. Delta T is just the change in the temperature, or we can say the difference in the temperature. Okay, the difference in the temp. Okay, and that's what everything means. So we now know what these mean. So let's go ahead and write a table down for all of our values. Okay, so let's see what we have. In the reading, we discover that we have Q. They came out and told us that the energy was 24,000. I'm a big fan of tables, so data tables, 24,800 joules. So I'm going to be sure to record my units there, joules. And notice that our units on our energy, joules, matches the energy units of our specific heat. That's great as well. So we don't have to worry about converting our Q. All right. And as we read our mass, we can go back and look for it. Our mass is 375 grams, so 375 grams. Our specific heat was given to us. Our C was 0.385 joules per grams times degrees Celsius. All right. And then it wants us to find how much does the temperature of the pan increase. So they're wanting to know the change in the temperature. And this change, since it's an increase, we know this increase is positive. Okay, so they're wanting us to find this. Now, once again, we know our Q is positive because they said that the energy was absorbed. This right here, when they tell you that the energy is absorbed by the pan, we know that it's going to be positive. Okay, so we know that this is a positive number. Now, if it's positive, you don't have to write the plus there. But if it is negative, you need to remember to put the minus sign on there. That way you can keep up with it. Okay, all right, so let's go ahead and plug in our values. Okay, I'm going to go ahead and scoot this problem down a little bit so I can write it and plug it in. All right, so here's the equation. Let me go ahead and move it down. That way I have it down here and I'm not writing it twice. I know, lazy. All right, so our Q was 24,000, so here we go. Our Q was 24,800. Now, I'm not writing my units because I use this data table over here. And units usually get sloppy and they get in the way and they can cause confusion. Now, my mass that I was given was 375. My specific heat is 0.385. And of course, I'm trying to find the change in my temperature. So I'm going to write delta T. Now, if you want to write just T there, that's fine. But this is my variable, delta T. Now, we need to do some algebra. So those of you that struggle with algebra, let me just say this. What you want to do is you want to get delta T by itself. So the rules are, since this reads 375 times 0.385 times delta T, we need to divide both sides by 375 times and also put in the denominator for division 0.385. So basically what we're going to do is we're going to take these two things here and we're just going to stick them down here underneath the denominator. Yes, it's that simple. Now you can always move things down like this if there is no plus signs or minus signs. Okay, if it's just all multiplication, division, you can just move things freely from numerators and denominators as long as you move them diagonally, or if you inverse both sides. Okay, so let's go ahead and take care of that. Okay, we want to get the delta T by itself. So on this side, to get delta T by itself, I'm not going to move the 24,800. It's already where it needs to be. I am going to move 375 and the 0.385. And when I move them, I'm going to put them down in this denominator. So 375, whoa, I forgot my 7. 375 times 0.385. So we're almost done. Now we just need to enter this into a calculator. So let's pull our calculator up, turn it on. Okay, we've got 24,800 divided by 375 divided by 0.385. And we get that. Now, some of you may not have liked the way I typed that into the calculator, so let me show you that that is okay. All right, in the numerator you have 24,800, okay, divided by, now this is where you can get paranoid and over specific and open up a set of parentheses. Then type 375 times 0.385. Now let's close those parentheses and press enter. Notice we get the same thing. So let me write that down. 171 point, what was it? 171.77 489, what was the other one? 18. Wow, that's totally too many digits, because in the directions it said to round your final answer to the nearest degree. Okay, so the nearest degree part would be the whole number, which is the 171. Okay, but you always have to look to the right. Now that's a 7. Now we can round our final answer. Okay, so our final answer is going to go up to 172. Now the question is, since this is the change in the temperature, do we put a plus sign or do we put a minus sign? Well, if you remember, in the very beginning when we were labeling everything, let's scoot this up so you can see this, we said that the Q, the energy, is positive because they said that it was absorbed. So we know that this is positive, okay? And plus, if you do the reading, you'll also see that it wants to know how much does the temperature of the pan increase. So we know to say plus. Now, we do need the units here. Now, if you go back, you can get that in a couple places. Here, it's degrees Celsius because that's what our specific heat value was in degrees Celsius in its units. And they also mention round your final answer to the nearest degree. Now, that is also making reference to Celsius because it wants to know it right here. It says in degrees Celsius. All right, so we're going to say 172 degrees Celsius. Okay. Now you may have a professor or a high school teacher that teaches your chemistry that wants you to be very specific, so you might want to write a sentence out that the overall temperature increased by 172 degrees centigrade, from its original temperature. So, all right, guys, I hope that this was helpful. If you have any other questions, just let me know. But if not, then y'all have a great day.